we're gonna kind of take our training wheels off from everything that we've done with like math so far in terms of equations. Okay, in the past, everything you've seen to date involved y equals some equation. Okay. Nothing is different about anything you've done with the math in terms of with the equations, but the way we write them has changed or will change today. Okay. So we're going to go from on the left there at the top, you can kind of see that XY notation. That's typically what you've seen. Okay, and that's just y equals 2x plus 3 is just a line. And then on the right there, it's you can see the difference. That's function notation. Okay, we're going to talk a little bit about why we like function notation versus the XY notation as we go through this lesson. But the way it's read is the value of f, so it's the value of the function, specifically the y value at x, or what's the y value for some particular x. Does that make sense? So if I were interested in, you know, like where's the graph at x equals 2, that would have some y value associated with it, just like a coordinate point, right? X, y, just a coordinate point. Okay, so it's mapping what the value of the function is for some value of x. Okay, and so when we see this here written, if we go down to the example, okay, f of 6. For me to write f of 6, we're going to write, I don't want that up there. We're going to see, we're just replacing. So you can notice f of x, f of 6. I'm just going to replace the x in the equation with the number it tells me to. And then it becomes very clear what the value of the function is given that value that I substituted in for x. Okay, so f of 6, we're just going to write 3 times 6 plus 1. Okay, so we're going to see f of 6 is going to equal 18 plus 1. Okay, so it's very clear, right? Like this is like what's nice about the function notation, it's almost like a table of values, right? Like we know now when x is 6, the y value is 19, right? It's very clear, right? It says the value, the y value of the function when x is 6 is 19. Okay, so f of x, the whole piece, is just physically replacing y in your equation. Okay, it's nice because you don't you could do a whole bunch of these substitutions and not have an ugly table of values sitting there. You have these nice f at 6 is 19. Okay, and f at negative 2 is going to be 3 times negative 2 plus 1. I mean negative 6 plus 1. So very clear. When x is negative 2, the y value of the function is negative 5, just like a table of values. Okay, that's pretty much all we're doing today, with some tweaks to that. Okay. Everyone okay? All right. Now, the same way in the past where we've substituted values of x's in and got y's out, I can also substitute values for y and solve for x. Okay, they go both ways. And so what they've told us to do here is they told us the y value of the function, this particular function, is 22. And it wants us to solve for the value of x that makes the y value be 22. Okay, so you're going to physically, whatever you see, if you see the x still present in the equation, it means you're looking for it. Right? And if you don't see it and it's been replaced, we'll just substitute that value in for x in the function. Okay? So this, I still see the x, it means that's the thing I'm looking for. So I'm going to physically take 22. 22 is f of x. And so I'm just going to replace it with f of x and solve for x accordingly, right? So I'm just going to write this. F of x turns into 22. That looks like something we've done before. Everyone in agreement? So you're just going to solve for x. Okay, make it a little bigger. So these things can go both ways. You can substitute values for x and solve for y, so you can substitute values for y and solve for x, just like a regular old equation that we've done a bunch of times. Okay, so just pay attention to what's being asked of you, and you can see what's being asked of you based on the way that the notation is written. Okay, if you still see the x, it means it's looking for it. If you don't see the x, it means it's looking for y. Okay, so we can solve this by creating a zero pair. We're going to get 21 has to equal 3x. Divide both sides by 3. And so x is going to equal 7. Okay, so that means to kind of finish these questions, it's nice to just finalize it and say, okay, f at 7 equals 22. So that's when we have just the equation on the page. But what happens if I have the graph? You're going to have to be able to look again at the notation and find the information that they're asking you to find. What's missing in A? Maybe not the best worded question. What is it I'm looking for in A, Dill? We have no, I'm not interested in the equation. All this is strictly just asking for. It's basically, okay, I have x. X is 2. I want to know what the y value is when x is 2. So you use your graph. You just read it off. Does that make sense? So go find, where's 2 on your graph? 2 on your graph is right here. 2 on the x-axis is right here. What's the value of the graph when x is equal to 2? Gabe? It's just 1, right? So you're going to stand here, and you're just going to look at your graph. Either your graph's going to be above the axis or it's going to be below it. You're just looking, you're standing at the value of x that they've told you to stand at, and look at your graph. And then just read off whatever the value is that's on the graph, right? So we know the y value that corresponds with x being 2 for this particular graph is 1. Okay? Okay. What about the next one? Done?
Y is equal to -2.
Right.
When it's -1.
Okay, so it says, wants to know what's the value of y on the graph when x is -1. Just go find -1. -1's right here. And look up or down. Well, you're going to look down because the graph's down below the axis, and you see, oh, it's -2. Okay, that's that point. Now we've thrown a little wrench at you now with C. What's C asking for?
X value of Y is at 6.
That's right, that's right. Right, so it's just flipping it. So where are you going now? You don't know X. What do you know? So where is the value of the graph, the Y value of the graph? 6. That's where you're going to go find it. It looks like there's there. Is that the only one? It's here as well. All right. So what's the value of x when the graph has a value of 6? We have 2 values of x. Yeah, Reese?
Plus or minus 3.
Yeah, it's plus minus 3, right? So x can be write it like this. I like the notation because it's like a Okay. So again, it's pretty much a table of values. It's just a fancy way of writing a table of values is what that is. Okay. Now the cool thing that we can do that's different from what we've done in the past is we can these are like kind of called composite functions, if you will, right? I can take one function and substitute it into the other one. Okay, so what we're going to see here, we're not looking for a specific numerical value anymore on a graph. It's asking for what happens if I take, here's my function h of x. H of x is equal to 2x squared plus 6x. It wants to know the value of the function when I substitute not just a number now, another function. Okay, so it looks like we're taking a linear function and substituting it into a quadratic one. And we're going to see what happens. So the long-winded answer can be condensed quite quickly here. Whatever this tells you over here, whatever this says to substitute, you substitute it in for x and just do whatever work is associated with that. Okay, so we're going to actually evaluate this function with respect to another function. So we're going to go h of n plus 3 is going to equal 2n plus 3 squared plus 6 times n plus 3. Whatever's on the inside of that function notation for x, you put it in for x and do whatever work you need to do to it. Okay? So now we have some skills from grade 10 a little bit, and grade 9. I think we've done this before. This idea of expanding and collecting like terms. Do we know what this means? Do we know what another way to write that? Dylan?
7 times 7 times 7 times 7.
Oh, that's an x. Sorry, buddy. It's an x. Sorry, but you're right. It's x times x times x times x. Everyone in agreement? That's close enough. We got the point. It doesn't matter what it is. It's to the power of 4. It doesn't matter what it is. So what's this then?
N plus 3 times n.
Yeah, it's just n plus 3 times n plus 3. It's a binomial times a binomial, which we've done before. What's the skill that you've used in the past to call that expanding two binomials? Gabe?
The rainbow?
The rainbow, or I gave you 3. You can use table or FOIL. FOIL being first outers, inners, last. Those should all be, well, one of those 3 things should sound familiar to you. Okay? So we write okay, and then what we're going to do is we're just going to do whatever expanding work we can do, right? So with the rainbow, something like this. Okay, and then we're going to take the 6 and distribute it into that second bracket. Okay, so each one of those arches represents a multiplication. Okay, so you should have like, and then at the very end, you still got to put that 2 in, but leave the 2 to the after. Okay, so we're going to go 2. N squared would be the first arch. That'd be the n times n, plus 3n, plus another 3n. I'll move it up, sorry. And then plus 9. And then we're going to add the distribution of the 6 into that second bracket, 6n plus 18. Okay, it looks like those 2 terms are, what do we say, similar, okay, or like. We're collecting like terms here. We're going to go 2 times n squared plus 6n plus 9 plus 6n plus 18. Okay, and now I'm going to deal with that 2. Are we okay or no? If you have a question with one thing in particular, just ask it, okay? And we'll identify where it came from. Okay, so now I'm just going to distribute the 2 in. 2n squared plus 12n plus 18 plus 6n plus 18. Just as a quick refresher, I'm not going to do this for the whole course, okay, but I can collect like terms being the n's can be collected together. If there was an n squared, I could collect those. There's no n squared, and then I can combine the two numbers. Okay, so we're just going to go 2n squared plus 12n plus 6n is going to be 18n plus 36. Okay, that would be written and simplified. I suppose if we really wanted to get crazy, we could factor that and simplify it even further, because that's just a simple trinomial, right? It doesn't say factor, but if I needed to, or simplify, it said fully simplify. So we have two numbers that multiply to 18 and add to 9. So if I'm doing my man method here, right? Two numbers that multiply to 18, add to 9. What do you think those two numbers are? One, 18, 2, 9, 3. 3 times what gives me 18? All right, it's 3 times 6, I think, works, and 3 plus 6 also works. So this would, I think, be the simplified version. It's a pretty loaded question given what we started with. Would everyone agree? Can kind of it just kind of tumbles, right? More work, more work. I don't know if in the past when I've done this question, I think I've maybe stopped here. Okay? Because it says simplify. Write and simplify. That's fully simplified in my mind after it's been factored. One could maybe make the argument that the where I drew that black line is simplified too, but.
That's what I say.
Okay, turn the page over. As long as everyone's okay, we'll turn the page over. Okay, another example, quick example here. I don't think this one will be as complicated, but. Okay, again, whatever you see in that place of where x should be, it's going in for x. Whatever it is. Okay? I don't think this one's as complicated as the last one. So we're just going to distribute the negative 3 in. We're going to get 5 minus 6 plus 15w. 5 minus 6 would be negative 1 plus 15w. And just for formality's sake, 15w minus 1. Write it in descending order. Is everybody okay? I think that's an easier example on the other side. A little less work. Maybe easier to wrap your head around that one. Okay. What about this example? If g of x is equal to x squared minus x minus 12, what value, maybe we should put brackets around the s because it could just be one value, that's possible. What value or values of x make g of x equal to 0? What's that asking you? It's asking you for the roots. set the equation, that's what this says, set the equation g of x equal to 0. Tell me what values of x make that true.
Okay.
Well, let's do that. G of x tells me to set it to 0, 0. It could be any number, by the way. Okay, it could be 3, could be whatever. You put the equation equal to whatever it tells you to put it to. Doesn't have to be 0. Okay? And then it turns into one of those like solving questions where you got stuff on either side of the equal sign. You just shuffle it over, make it be 0, and solve. Just like what we finished doing 2 days ago. That sheet I gave you. It said CUDA at the top. Okay, where you had stuff on either side of the equal sign and we shuffled and solved with factoring. Okay, so 0 is going to equal x squared minus x minus 12. What's that look like? You see something like that, you should be at the point where it's just screaming at you of what to do. You're just going to factor it. Okay? What kind of factor are you going to do? Or what kind of trinomial is it? Sorry, I'll move it up. Sorry, you see. It's a simple trinomial, right? So I'm just looking for two numbers that multiply to negative 12 and add to negative 1. All right, so you can sit there and ponder for a couple minutes, or you can just go through the process. 1, 12. Check the multiplication. Is that ever going to add to negative 1? No chance. 2, 6. That ever going to add 12 or negative 1? No. Let's go next one. 3. 3 times what gives me 12? Oh, 4. Is there a way for me to turn those two factors, or is there something I could do to those two factors to satisfy both of the conditions? Gabe?
Turn the 4 negative.
The 4 can be negative. Okay, if I make that 4 negative, 3 times negative 4 satisfies the multiplication to negative 12, and 3 minus 4 gives me negative 1. So 0 is going to equal your factored version, x plus 3 times x minus 4. Okay, so solve for x. X plus 3 equals 0, and x minus 4 equals 0. So x is going to equal negative 3, x is equal to 4. Okay, and then just to finish these questions off, just go g of negative 3 equals 0, and g of 4 equals 0. It's like a table of values, right? You're just keeping track of what's what. Okay, these are, what are these? We have a name for these. What are they?
Like on the intercept.
What kind of intercept? X-intercepts. How do we write x-intercepts typically in the past? Hey, it's a point. It's a cardinal point like all the other cardinal points you've done, like negative 3, 0, and 4, 0. You see how nice the function notation, you can see that there. The function notation just says what the point is. Okay. A couple more and then you guys can do some work, okay? The last one's a little different. Okay, again, I think this one's maybe a little easier than the other one. Same thing. It's telling you the value of the function is 23. So that's what's going to go in place of h of x over here. So h of x is equal to 23. It has to be equal to 4x plus 3, the function. Okay. So you're going to subtract 3. Subtract 3. We're going to get 20 is equal to 4x. Divide both sides by 4. X is going to equal 5. Okay, I can tell your test is going to have a question like this on it. It's just going to have a couple of, like one other lesson mixed in with it. Okay, so what we're going to see here, what's this question asking us to find? So let's think about the flow of the lesson today. I want you to think about like what is that specific notation saying, and then what is the question asking you to do, RJ?
So basically, we're taking two outcomes of the function and basically subtracting one another.
Okay, so I like the use of the word outcomes. What's the outcome of a function? When we substitute values of x, we get out what? What happens when I substitute x's into an equation? What comes out the other end? Y values. So RJ used outcomes or outputs or whatever, right? But really what this is asking us to find is we'll write this down so it helps. It's find the difference and that's what that's saying. Give me the difference in the y values, right? When x is 2 and x is equal to 1. So you're going to do those two things separately. Okay, so give me the value of the function, because these are going to get more complicated in your homework. So let's just try and follow a little bit of a process. I don't know what the value of the function is at 2, and I don't know the value of the function at 1 either. So let's find them. That'd be step 1, step 2, and step 3 would just be to subtract the two results. Do it in stages. Okay, so we can go h of 2 is going to equal 4 times 2 plus 3. Well, that's 8 plus 3, which is equal to 11, right? So that's h of 2 is equal to 11. Put a little box around that is some information you know. H of 1. Okay, and then we're going to go, okay, I know h of 2 and I know h of 1, right? So we're going to go